On this problem, we're given a right triangle, and it has pretty nice angles, 45-degree angles to go along with that right 90-degree angle. We're also given one of the side lengths. So we're given A is going to be 6. So I'm going to go ahead and label that here on our triangle. We're tasked with finding the other two side lengths. So we need to find B and we need to find C. To do this, what we're going to do is we're going to use Sohcahtoa, trigonometric ratios. So we have sine is equal to the opposite side over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So for our purposes, I'm going to go ahead and focus on this 45-degree angle in this corner. Therefore, if we label the sides, this is going to be our opposite side, this is going to be our adjacent side, and this will be our hypotenuse across from the right angle. I find labeling the triangle helps out as far as identifying exactly what I'm plugging in when we plug it in. With this one, let's try to find B first. So with that, we have the trigonometric ratio that involves the opposite side and the adjacent side. So we have tangent is opposite over adjacent. So let's set this up with tangent. So we can say tangent of our 45-degree angle is going to be opposite, in our case 6, over adjacent B. Tangent of 45 is a nice angle because it turns out being 1. That should be one of these typical ones that comes up enough that we get that one memorized, along with 30 degrees and 60 degrees. All right, now to find B, we can't solve for it while it's in the denominator, so let's multiply both sides by B, and we get B also equals 6. We'll label that on our triangle. And now finally, to find C, we have a couple different options. Either we could set up the trigonometric ratio, either sine or cosine, that's going to involve the hypotenuse. And if we did that, let me see, we would say sine. I'm just choosing sine. We could easily use cosine as well. We could say sine of 45 degrees is going to be opposite 6 over the hypotenuse C. Sine of 45 degrees works out to be the square root of 2 over 2 equals 6 over C. And then with a little bit of solving down, we can get C by itself. By multiplying both sides by C, these will cancel out on the right-hand side. So we have C times the square root of 2 over 2 equals 6. We'll multiply both sides by 2. C times the square root of 2 equals 12. And then to get C all by itself, we'll divide both sides by the square root of 2. All right, so we can say C is 12 divided by the square root of 2. We may be able to get a little bit better answer here by rationalizing the denominator, by multiplying both numerator and denominator by square root of 2. That'll give us 12 times the square root of 2 over the square root of 4, which reduces down to be 2. And now 12 over 2 will make 6 square root of 2. Now, an alternate way to do this, instead of using another trigonometric ratio like I chose to do, would have been using the Pythagorean theorem. A squared plus B squared equals C squared. So we have A is 6, B is 6. So we have 36 plus 36 equals C squared. That's 72 equals C squared. Apply a square root to both sides, and we don't need to worry about the positive and negative case in this one because it's a side length, it's a real life situation, and that works out to be the square root of 36 times 2, breaking that 72 apart using a perfect square as one of the factors. So you can say the square root of 36 times the square root of 2, which is again 6 square root of 2. Same answer, two different directions you can go about finding it. All right, hope this helps in setting it up and labeling our sides. Get down Sohcahtoa. It makes a big difference. And also memorize the three angles, the 30, 45, and 60, as you plug them into these trigonometric functions. All right, good luck till next time.